Today we shall consider the two-sample t-test. We discussed earlier that a t-statistic arises out of a normal population. So this is an application of that t-statistic into the testing of hypothesis. A common task in research is to compare two populations or groups. To be specific, we can compare two populations in terms of their means. For example, we may feel like comparing two groups of children in terms of their mean height, two groups of adult individuals in terms of their mean income, so on and so forth. So, researchers may wish to compare the income level of two regions, the nitrogen content of two lakes, or the effectiveness of two drugs. So, you can imagine how vast the application of this test is. An initial question that arises is what aspects or parameters of the population should be compared. We might feel like comparing the population averages, the population medians, the standard deviations, and so on and so forth. But in t-test, we shall compare the two population means. To be specific in statistical terms, here we would like to test H0 mu1 equals to mu2 against any one of the possible alternatives, mu1 not equal to mu2, mu1 less than mu2, or mu1 greater than mu2. One thing I would like to remind you that here the null hypothesis will be tested against any one of these alternatives. The null hypothesis cannot be tested against all possible alternatives simultaneously. So here basically we are discussing three different tests together because they are similar in nature. Here mu1 and mu2 are nothing but the means of the two populations under consideration. Before going into the testing procedure, we should know the requirements and the assumptions behind this test. Unless these requirements are satisfied and the assumptions are met, we cannot perform this test. So this is very important to know the requirements as well as the assumptions behind the two-sample t-test. A two-sample t-test should be used only when the data has been collected on one variable for two populations. So that means if we collect data on height, we have to collect data on height from two different populations. Similarly, if we want to compare the income figures, then the data on income is to be collected from two different populations. That means there will be a single variable and there will be two populations under consideration. The two-sample t-test assumes that all errors in the data are independent. Now, what do we mean by the errors? The term error refers to the difference between each value and the group mean. Now see, when we draw a sample from a population, there will be several observations. So for these observations, there will be a mean. So the difference between each observation from the group mean will be called the error. The results of a t-test only makes sense when the scatter is random, that whatever factor caused a value to be too high or too low affects only that value. That means the errors are independent of each other. This is a very important assumption of two-sample t-test. A t-test is only appropriate to apply in situations where the data represent variables that are continuous measurements. That means the data cannot be categorical, the data cannot be discrete. The data are to be continuous. So we may compare the heights, we may compare the weights, we may compare the incomes, so on and so forth. But there may be one situation, suppose we have two populations. The populations have been categorized or classified according to blood groups, say A, B, and O. So the first population is classified according to the blood groups in 4 categories. Similarly, the second population is classified according to the blood groups into 4 categories. Now, we may feel like comparing the two populations, obviously on the basis of the sample, regarding the proportion of members belonging to different category of blood groups. This cannot be done through t-test. This is obviously beyond the scope of our study right now. Maybe later on you will study this, but this is beyond the scope of the t-test. We have to remember that whenever we apply t-test, the variable should be absolutely continuous in nature. Otherwise, we cannot apply t-test. The results of a t-test should be based on a random sample and only be generalized to the large population from which the samples were drawn. So, we have to we have to resort on the sample. We talked about this thing again and again earlier also. That means the sample has to be a random sample. Now, can you tell me why the sample is necessarily a random sample? So the samples are to be random samples, otherwise sampling bias may creep in. For example, suppose we want to compare the income of two populations in terms of their mean. Now, if we select subjectively some individuals who are under the poverty line, obviously the result will be erroneous. So that is why the samples are to be random samples strictly. The most important assumption is the populations are to be normally distributed. What do you mean by that? As with all parametric hypothesis testing, the two-sample t-test as well assumes that we have sampled our data from a population that follows a normal or a Gaussian distribution. Because if you can recall, when we studied t-distribution, a t-statistic is derived from a normal population. So that is the basic assumption that we have to keep in mind. While this assumption is not as important with large samples, it is very important with samples of smaller sizes, especially for sample sizes less than 10. Now suppose my data does not come from a normal population or a Gaussian population. Then what we have to do? There are way outs. Basically, there are some options through which we can overcome this difficulty or drawback. One option is to transform the values to make the distribution more normal, more Gaussian. This transformation may be done by taking the reciprocal of all the observations or taking the logarithm of all the observations. In many situations, it is seen that if the original observations do not follow a normal distribution, then their reciprocals or logarithms follow a normal distribution. So these transformations may be used. Another choice is to use Wilcoxon signed rank non-parametric test. It is a non-parametric test, that is, we do not assume any parametric aspect in this test, and we will not be discussing this test in our course of study. A final option is to use t-test anyway. That is, we will go on performing the t-test because t-test is more robust for departures from Gaussian or normal distribution. So we will go on conducting a t-test even if the data do not strictly follow a normal distribution. The two samples are to be drawn independently of the two populations. That means we have two populations. We have to take two samples out of these two populations. So using some random number table, we will draw the samples from the first population, sample observations from the first population. Now, while drawing the sample from the second population, we have to go for fresh randomization. That is, we have to take the starting point again independently of the first population. We now go into the actual procedure of t-test. Suppose we have two populations with means mu1 and mu2 respectively. And we will consider the two-sided problem here. The one-sided problems may be discussed simultaneously. So we will test H0, mu1 equals to mu2, that means the two population means are same, against H1, mu1 not equal to mu2, that is, the two population means are different. Suppose we draw two random samples of sizes n1 and n2 from these two populations, and the random samples are to be drawn independently. x1 bar and x2 bar are the sample means, while s1 square and s2 square are the sample variances. We will not repeat the formulae for means and variances anymore because we have already come across these formulae. Then we calculate something called s square. You can see on your screen, it is n1 minus 1 into s1 square plus n2 minus 1 into s2 square, the whole thing divided by n1 plus n2 minus 2. This is called the pooled variance. We have s1 square, the first sample variance. We have s2 square, the second sample variance. Now we pool s1 square and s2 square to get the pooled variance, which we denote by s square. The test statistic t is then denoted by x1 bar minus x2 bar in the numerator divided by s, that is the square root of s square, then root over 1 by n1 plus 1 by n2. We can show that this follows under H0 a t distribution with n1 plus n2 minus 2 degrees of freedom. Now it's a two-sided test, so we will reject h naught if the numerical value of t or the modulus of t is greater than t alpha by 2 n1 plus n2 minus 2, where t alpha by 2 n1 plus n2 minus 2 is the upper alpha by 2 point of a t distribution with n1 plus n2 minus 2 degrees of freedom. And these values are tabulated in biometric tables as well as from any statistical software. We can obtain these tabulated values. Now, what are the pros and cons of t-test? That is, what are the advantages and what are the disadvantages of t-test? That we will discuss one by one. First, we will discuss the advantages or the pros. It is essential for generalization. That means the result achieved after the t-test are useful for concluding if they are actually correct, they can be applied to the entire population. See, we are testing on the basis of a set of sample observations, and whatever decisions we are taking on the basis of these sample observations. So we can generalize this idea to the entire population as well. So this is one of the advantages of t-test. Robustness. It assumes that the independent samples of two populations are normally distributed and have the same variance. This is one very important assumption in t-test that we take care of. That is, we assume that the two population variances are same. The t-test is fairly robust to the violation of the first assumption, that is the violation of the normally distributed population assumption, since there are two samples from a population that have unequal variances. So, this t-test is robust in the sense that although there are assumptions, but t-test will remain more or less valid even if these assumptions are violated. That is why t-test is very popular test for comparing two populations. Now, you see, when we talk of two populations having the same variance, do you think we should perform any other check before performing the t-test? Just looking at this point, that is, we are assuming that there are two populations having the same variance. So do you think we should perform any more check before conducting the t-test? Talking of the fact that whether there should be any check before performing the t-test, it is advisable to check whether the two population variances are same before conducting the t-test. T-test is very easy to compute because we just collect two samples and even if we have a calculator or a computer, we can calculate the sample means, we can calculate the sample variances, the pooled variance, pooled standard deviation, and then the t-statistic. So it's very easy to calculate. This is one of the very major advantages of t-test. T-test is also easy to interpret because here the output tells us how different the means of the two groups are and also the mean of each group and the average difference between the groups. A larger t-score indicates that the groups are different and a smaller t-score indicates that the groups are similar. Why this is so? That is because you see, in the numerator of the t-statistic, what do we have? x1 bar minus x2 bar. That means the difference of the two sample means. Now, larger the t-score or the value of the t-statistic, that means the two sample means are much more different. On the other hand, a smaller t-score indicates that x1 bar and x2 bar are close to each other. That means the two samples are not much more difference, or rather the difference is less between the two samples in terms of their means. Or in other words, we can say that the two groups are similar. For t-test, it is more or less easy to gather data. A small number of subjects for independent t-test samples are required. Only a small numbers, not very large amount of sample size is required. Only one value from each subject is needed. It requires values of subjects from the two sample groups on a quantitative variable. From each subject, that means from each informant or from each object, we collect data on a single variable. right? And that single variable has to be quantitative. To be more specific, it should be continuous in nature. T-test enables us to compare the average values of two dataset samples and determine whether the sample subjects come from the same population. Here, basically, we are comparing two populations in terms of their means. Now, suppose H0, the null hypothesis, is accepted. Then what do we mean by that? That means there is no difference between the two populations in terms of their means. So that means the two populations are identical in terms of their means. So that means if we accept the null hypothesis, that will essentially mean there is no difference between the two populations in terms of their means. And if we reject the null hypothesis, we will conclude that the two populations are different when we consider the means of these populations. The t-test formula for independent samples is easy to understand. This makes it easy to know what is going on without needing much statistical training. You see, as we mentioned earlier, that the t-statistic, a larger value of the t-statistic will indicate that the two samples are different, while a smaller value will indicate that the two samples are not that much different. So it's very easy to understand. So that is why t-test is done even by non-statisticians. In sociological field, in biological field, there is vast application of this t-test. So this is because t-test is very easy to understand and to interpret. So much statistical training is not needed while performing a t-test. And that is why it saves time as well. Because the sample sizes are small, even with small sample size we can perform t-test. So time will be saved. And it does not save only time and money, but saves the time required to collect and analyze large amount of data. Because we are not going for large amount of data, so for calculating sample mean we will take lesser time, for calculating sample variance we will take lesser time. So it will not take much amount of time and money in terms of performing the t-test. T-test repeated measure design results in small effects since the amount of error from one samples is very small. It also leads to good control of individual differences. Only one group is available for testing, and this can result in less noise of data. When we perform t-test, as we have mentioned, we have small amount of data, so there will be less noise. Less noise means that there will be less amount of error. So that is why we have a control of individual differences in t-test. And it provides necessary information as well. It gives us all the information we need to know about the population. So a population, we mentioned earlier also, is characterized by its parameters: population mean, population variance, population median, etc. etc. Now here in t-test, we consider population mean only, and we are interested only the difference in the means. So you see that parametric information is with us when we perform the t-test. That means under H0 we assume that the two population means are equal, and under H1 we assume that they are different. Now we will come to some drawbacks of t-test. It is difficult to find subjects. Getting the subjects for the sample data is very difficult and also a very expensive part of the research process. It is not only a drawback of t-test, it is the drawback of any statistical test. When we perform a test, we have to resort to sample observations. We have to collect data from the sample. Now, can you tell us what difficulty one may face while collecting data on samples? So when we collect data for any testing problem, we have to go to each and every individual for collecting data. Now suppose we collect data on income. It may be possible that the individuals do not feel like furnishing their income figure. So we have to frame a questionnaire, or we have to put indirect questions. So this is the most major and expensive part of any testing problem. So when we have to collect data, we have to think of these things. In statistics, we just do the testing calculations, we do the analysis and all these things. But the most important part is collecting data, and in t-test specifically we have to collect data from samples of two different populations, not from a single population. So that is a bit difficult thing for a t-test. When relying on paired sample t-tests, there are problems associated with repeated measure instead of differences between group designs, and this leads to carryover effects. So this has to be understood that t-test may have a carryover effect. So we have to be cautious about this carryover effect while performing a t-test. There is small amount of noise. That is also one problem with t-test. Also, although you may not worry about individual differences between the group data sets, there is still an individual difference between the groups, and not every sample will react in the same way, thus creating a small amount of noise. So that means even if we see that the t-test is accepted, that means we conclude that there is no difference between the two groups. But this is not always true. Some small noises may always creep in while we conduct t-test and we accept the null hypothesis. So we have to be aware of that. It is mainly because of the outliers present in the data. Now suppose we have two data sets. One data set do not have any outlier, the other data set has got some outliers. So that means the data set which has outlier, that is an observation which is widely different from the others, the noise is much more for that particular data point. So that particular sample will contain that noise, large amount of noise. On the other hand, the other sample may not contain that noise. But since we are comparing the means, it may be that t-test gets accepted even when noise is present in the data. There is an environmental impact as well. Independent t-test can help you determine the difference between sample groups, but cannot help in controlling the effects of the environment. Environment change may affect the output of the t-test. Suppose we want to compare the working ability of two groups of individuals. Say one group of individuals residing in hill areas and the other group in plain land. Now if we compare them in terms of their working ability, then there is an environmental difference in the two geographical region. So t-test will not account for this environmental impact. So that we have to consider. There may be several factors that creep in attributing to the difference between the two groups. But the test is not responsible for that. So these environmental impacts are not permitted by t-test. T-test cannot be used for multiple comparisons. This is very important because it results in type 1 error. What is a type 1 error? If you can recall, it is the error of rejecting a null hypothesis when it is actually true. When conducting a paired t-test among a group of samples, it will be difficult to reject the null hypothesis. So that is why there will be type 1 error. There may be a loss in the degrees of freedom. When the degrees of freedom of a group test becomes lower, you need a higher t-value in order to reach the t-test significance, and this creates a greater trade-off between the greater power leading to fewer degrees of freedom. So if you want to go for greater power, more powerful test, the degrees of freedom will be less. So there will be a trade-off. Finally, the reliability of the data. If the data collected violates the assumptions of the t-test, then the output is unreliable, although t-test is robust to the assumptions. But still, if the assumptions are violated, then the results of the t-test will not be reliable. In the next course, we will see how we can apply one sample t-test and two sample t-test or independent sample t-test in real life problem. So in this particular lecture, we understood what is a two sample t-test. Earlier, we understood what is a one sample t-test, the assumptions they are based on, and how to perform these t-tests. Thank you.